All right, in this video, we are going to solve this exponential quadratic kind of equation over here. It's a mix of the two, I guess. And you may be wondering, is there a algebraic way to solve this, or do we have to do a logic way? I'm going to kind of show it both ways. Let's start with the algebra method. If I want to do the algebra method, the first thing I'm going to do is I'm just going to log both sides. And then I'm going to bring down the exponent using the rules of log. Log of 1 is just 0. And now I'm just going to factor this one over here. You don't really need to factor that one over there. I'll explain why in a second. So that's just x minus 2 and x minus 1 as a simple trinomial. And now I can basically split this up because if any of these are 0, then the final answer will be 0. So I can get over here x equals to 2, x equals to 1, and over here, this whole thing has to equal to 0. So then I'm going to move the log to the other side, so it just becomes 10 to the power of 0, which is just 1. And then I'll move the 1 to this side and subtract it. So you get x minus 5 and x minus 1 equals 0. So two solutions here. Oops, 4, not 5. Silly mistake there. So you get x equals to 4 and x equals to 1. So it seems like we have three solutions in the question because 1 is repeating. So we'll have x equals to 1, x equals to 2, and x equals to 4. Now, solving algebraically, you might think that this is the right solution, but this is not the best way to do this question for a couple of reasons. First of all, when we get a solution of 2 and 1, we got to make sure that this over here is going to stay a positive number. And then second of all, there might be other solutions to this question that we have not proved algebraically. So how would I solve this question if it was in the test? I would actually solve this question logically. Let's pretend like we have a to the power of b equals to 1, where a is this quadratic equation here and b is that quadratic equation there. And we want to see when this equals to 1. How many possibilities do we have for this? Well, we have our first case where basically the exponent equals to 0 because anything to the power of 0 is always 1. But there's an exception to that rule. A cannot be 0 because remember, 0 to the power of 0 is an indeterminate case which has no solution. Basically, b has to equal to 0, but a cannot equal to 0. That's my first case right there, which is basically the same as that. You're just taking the exponent x squared minus 3x plus 2, and you're making it equal to 0. Just taking the exponent, making it equal to 0 and solving it, we'll just get x minus 2 and x minus 1 equals 0, which gives us the first two solutions of 2 and 1. But now we have to take these solutions, sub them in the base equation over here, and make sure we do not get 0. So 2 squared minus 5 times 2 plus 5, that's 4 minus 10 plus 5, it's negative 1. So this solution is good because it'll give us negative 1 to the power of 0, which is basically positive 1. And then let's sum in this solution, 1 squared minus 5 times 1 plus 5. That is positive 1. So we have 1 to the power of 0, which is also a good solution. So these two solutions right here are definitely good solutions. Let's do the second case next. In the second case, If I want to get a 1 on the other side, I know that the base, if the base equals to 1, basically A equals to 1, then it doesn't matter what the exponent is because 1 to the power of any number will always give me a solution of 1. So it doesn't matter what my B value is in this case. I just need the A value to be 1. In my equation, that's the A value right there. So x squared minus 5x plus 5 equals to 1. Then we have x squared minus 5x plus 4 equals to 0. And then again, this looks very similar to what we did earlier. So x equals to 4 and x equals to 1 are my solutions here, which basically these answers match these answers over here for my first two cases. But again, like I said, I would prefer to do it this way because this way you can always test your solutions. Technically, you could do it the other way as well. There's also going to be a third case over here, which the algebra solution doesn't take an account for. What's a third way I can get positive 1 over here? Well, let's pretend that A is negative 1 and B is an even integer because negative 1 to the power of any even integer will give me positive 1. And this is the third case that's not taken care of in this question. So let's make my A equal to negative 1. So x squared minus 5x plus 5 equals negative 1, which means x squared minus 5x plus 6 equals 0. If I factor this, I'll get x minus 2, x minus 3 equals to 0. And this gives me another two solutions of 2 and 3. Now, 2 was already included in the solution over there, so we don't have to repeat it. But 3 is another potential solution. So what you want to do is we're going to sub in all our solutions to test. I already tested out 1 and 2 over there. So I know that x equals to 1 and x equals to 2 are definitely good solutions. And I came over here to my second case, 1 repeated, no need to test it again. But then I have 4, and then for my third case, I have to test 3. Let me test 3 in this equation over here. 3 squared minus 5 times 3 plus 5. I'll just do that in my calculator. You could do it mentally as well. That's just negative 66. Oops, no, it's not. I made a mistake in my calculator. It's actually negative 1. And then let me do the exponent. So 3 squared minus 3 times 3 plus 2 is 2, and negative 1 to the power of 2 is positive 1, which means that x equals to 3 is definitely a valid solution as well, one that you would have missed if you tried the algebra method. And then finally, let's do x equals to 4 by subbing 4 into the base over there. So 4 squared minus 5 times 4 plus 5 is positive 1. And then the exponent doesn't matter, but I'll just calculate it anyway. 4 squared minus 3 times 4 plus 2 is 6. 1 to the power of 6 is 1. So 4 is also a good solution. So in this question, we have a total of 4 different solutions, and all of them are valid. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.